Hello guys, so we are back again and today we are going to do the multiple choice question which we have started earlier, okay, of sequence series. Okay, the question number 6 of multiple correct is as follow, which says if a square plus 2bc comma b square plus 2ac comma c square plus 2ab are in AP, then the first option is a minus b into c minus a comma a minus b into b minus c comma b minus c into c minus a are in AP. The second option is b minus c comma c minus a comma a minus b are in HP. A plus b comma b plus c comma c plus a are in AP. A square comma b square comma c square are in HP. Okay, so how can we approach this problem? Okay, the approach is very crucial. Okay, first it is a multiple correct option. Okay, so you have to target the question, okay, answer as per the option also. Okay, that is also a crucial thing. Okay, in every question, okay, when multiple correct option appears. Okay, so one thing that it is a AP, so should I do one thing? That listen, when there is AP, two things we do. We, if I say that a b c are in AP, you will tell me that do this thing, a 2b is equals to a plus c. Okay, fine. Okay, instead of doing this, can I do this, b minus a and c minus a? Okay, so we will do this thing. Okay, we will not waste our time multiplying it by 2 and then we will directly do this step. Okay, because we can directly see that, okay, here difference negative are there, so if I take difference I can get any options. Okay, that is the probability. Okay, so we gonna use our common sense in more advance. Okay, these problems of multiple correct are quite more tricky than single correct. Okay, so let's begin this problem. So what we are going to do, first let's b square plus 2ac minus a square minus 2bc, then c square plus 2ab should be equal to minus b square minus 2ac. Fine. Okay, here till here anybody can do this. Okay, now let's arrange the things. Okay, so here what we can see, b square minus a square, okay, plus 2ac minus 2bc, okay, c square minus b square plus 2ab minus 2ac. Fine, no issue. Now we want to get b minus c, a minus b, because I have done this step. My purpose was to create this a minus b, c minus b. So how can we create? If I take 2c common, then I can create. Fine. If I take 2a common, then also I can create. Okay, and what else we can do? What else we can do? Okay, here we can apply a square minus b square. Okay, so b minus a, okay, c, okay, we can see b minus a and c minus. Here if we take 2c common, okay, 2c common, okay, 2c common, then we are left with a minus b. Fine, a minus b, right? And here same we will do c minus b and c plus b. Okay, and here we will take what, 2a common. Okay, this much step you should be very understood well. Why we proceeded this way? Okay, what was our main intention? Our main intention was to tackle, means target the question as per the option, because multiple correct option can be there. Okay, and in AP, since we take difference, so the probability of getting these answers, okay, instead of this, okay, if we got this answer we can check by AP. Okay, and then we will think of something what clicks us first. It is very important. Okay, so after this step you can clearly see a minus b is common. Okay, so I will take a minus b common here. Okay, why I didn't take b minus a common, that can also be a doubt. Okay, because if I am targeting this negative, okay, these options, a minus b is present everywhere, it is not b minus a, so that's why I am taking a minus b common. Okay, so what I am going to left with here, if I have to take minus common here. Okay, so first here if I take a minus b, 2c will be left. Here I have to take minus common, then it will become a minus b, so minus b minus a will be left inside. Okay, please understand this step. I have taken minus outside, then it will become a minus b, and this minus will go inside of that because a minus b have taken common. Similarly will happen here, I will take b minus c common. Okay, you can see here the same thing will happen here, 2a minus c minus b. After this step, a minus b, we can do one thing, c minus b, we can make it c minus a. Okay, now you can see we are creating something like that, very similar, b minus c and a minus c and a minus b. Okay, so now we are doing something. Okay, now after this step what we can do, a minus b into c minus b and a minus b into c minus a. Okay, and here b minus c into a minus c, and then b minus c into a minus b. Fine, this step is very means clear to you. After this we have to can check, can there be any term same? A minus b, a, b minus c, c minus a, c minus a, b, b minus c. B minus c is there, a minus b is not there. Okay, a minus b there here, but b minus c also. Okay, these two terms are same, but the problem is here. Okay, b minus c is there and c minus b. Yeah, if I can check, there is b minus c, there is no c minus. B minus c is there is no c minus b. Okay, so we will change this, we will make it minus a minus b, then it will become b minus c. Fine, and then it will be a minus b into c minus a. Okay, then b minus c into a minus c, and plus b minus c into a minus b. Okay, now after this we will shift it that side. Okay, which will create it twice. Okay, and we will move it this side. Okay, and now let's check, is there any change here? A minus c is there? No, there is c minus a, there is no. So here also I will take a minus b minus c, a minus c minus a, it will become c minus a. This will be as it is, b minus c, a minus b, and here it will be minus a minus b. Okay, I'm taking single step so that you can understand more clearly. A minus b and c minus a. Okay, first we take common here. Why? Because we want to create it similar like this. Okay, and similar like this, that's why we have taken minus here. Okay, in the next step, now let me take the next page. We will move this thing that side, then it will become positive. We will move this thing that side, then it will become positive. Okay, so here if I move it that side, I will be left with a minus b, c minus a. Okay, this thing will come that side, which will become plus b minus c into c minus a. And in the next step, okay, you can see it will become twice, because it is negative, it will add on, it will become a minus b into b minus c. Now isn't this like AP condition where the terms are these? Okay, so the first condition is right, so the first is correct. Okay, correct. Now to create now can we prove from this thing? Okay, how can we prove? Okay, if I divide by a minus b, c minus a, and b minus c by 3 terms, let's see what we get. We are getting here b minus c, here we will get a minus b, here we will get 2 upon c minus c. So it is just a reverse, it is AP. Okay, it is AP. Okay, now the reverse term, 1 upon b minus c, 1 upon a minus b are in AP. So the reverse means what? B minus c, c minus a, and a minus b will be in HP. In HP. Okay, this much is very easy. Okay, but now let's check for third and fourth option. Now just tell me, can we create a plus b? Okay, because here also there was minus. Can you tell me an AP condition by which we can create? No, we cannot create. So it is very difficult to create these terms. Okay, and so just go with the means highly probable common sense which you can use, means the chances of making this was very high. Okay, because in AP the basic formula only we can develop that. Okay, and they will not ask you any very difficult thing. Okay, in multiple. Okay, now let's move on to the next question. Okay, let me get the next page. The next question is as follow, which is this question: if the sum of an infinite GP p comma 1 by p comma 1 by p square is 9 by 2, then the value of p is. Okay, this question should not be asked because it is not that much good level. Okay, but doesn't matter, our job is to solve sum of the term. Okay, infinite GP is what? A upon 1 minus r, very easy. A is what? P. R is 1 upon p. Okay, 1 upon p means 1 upon p, which will give me p square upon p minus 1. Okay, now if this value is given equal to 9 by 2. Okay, if it is given equal to 9 by 2, then what we can do is we multiply 2p square is equals to 9p minus 9, giving me p square minus 9p plus 9 should be equal to 0. Okay, now we can if we solve it further, what we are getting, okay, we will get 2p square minus 6p plus 3p plus 9 should be equal to 0, giving me 2p p minus 3 into minus 3 into p minus 3 should be equal to 0, which will give me p is equals to 3 by 2 or p is equals to 3. Okay, so is there any option? Yes, second and third are the answer. Okay, so this question should not be asked because it is just a formula application. Okay, now let's move on to the next question. The next question is this eighth question. The terms of an infinitely decreasing GP. Okay, listen this. Decreasing GP having common ratio R in which all the terms are positive. The first term is 4 and the difference between the third and the fifth term is 32/81. Okay, now it is a decreasing GP. Okay, now decreasing GP doesn't make you feel like that the R is negative. Okay, don't get until they mention you. Okay, having common ratio R in which all the terms are positive. Okay, now that is quite amazing thing because value is decreasing but the sum will always remain positive because the terms are positive. The first term is 4. Okay, so I have got one information that the first term is 4 and the difference between that a3 minus a5 is nothing but 32/81. Okay, in GP I have told you how to consider term. This will be AR square, this will be AR power 4 and this should be equal 32/81. Now if I divide throughout by 4 because a will be 4, so I will be left with AR r square minus r power 4 into this will be 8 and 81. Okay, then we will what do, we will cross multiply giving us what, 81 r square minus 81 r power 4 is equals to 8. Now we will just arrange them. 81 r power 4 minus 81 r square plus 8 should be equal to 0. Now let r power 4 is equals to m square, then r square is equals to automatically m, which will give me 81 m square minus 81 m plus 8 should be equal to 0. Okay, if I solve this, what I'm getting, 9 r square minus, okay, sorry, 9 m square minus 8, sorry, I am doing it. Okay, 9m minus 8 into 9m minus 1 should be equal to 0. Okay, giving me m is equals to 8/9 and m is equals to 1/9. But if you remember properly, our m was what? M was equal to what? R square. Okay, so if m is equal to r square, then r square is equals to 8/9 and r square is equals to, okay, r square is equals to what? R square will be equal to 1/9 also. Okay, then what value of r? Now here you will get plus 1/3 and minus 1/3, but remember they are telling all the terms are positive. Terms will be positive only if r is positive, because in GP when you move, you multiply throughout by r. Okay, then next time you multiply by r, in the next r square, in then third term r square, in the fourth term r cube, like that. So r will always be positive. Okay, so you will consider what? 1/3. You will reject minus 1/3. Fine. From here you will again reject the negative one. You will take 2/3. Okay, fine. Okay, now this thing is means you can understand. Okay, you have considered that. Now they will give you sum also. Okay, now sum of the, okay, this the option saying sum of the infinite term is 6. Okay, we have checked, so first and second is properly correct. Now we have to check. Okay, this was previous question. Okay, we have to check for the options. The sum option will be what? The first one is what? 4. Okay, 4 upon 1 minus 1/3. Okay, which will give me 3 minus 1 means 4/2 into 3, which will give me 6. Okay, fine. And the next one, okay, let's find out the next one also. 4 upon 1 minus 2 root 2/3. Okay, although this will give me nothing but 3 minus 2 root 2, but doesn't matter, they have asked us only this one only. Okay, so this one is of no use. Okay, no use. Okay, but third is also correct. Third is correct. Okay, so our three options all they are correct. Okay, now let's move on. Let me take this page also. Okay, so the question number 9 is as follows. The question number 9 says, if let a1 comma a2 comma a3 and so on, a and b in GP, okay, such that 3a1 plus 7a2 plus 3a3 minus 4a5 is equals to 0, then common ratio of GP can be what? Okay, so this question, okay, what they're saying, the first thing, 3a, okay, if I consider GP, this I can write 3ar, this I can write 3ar square, this I can write 4ar raised to 4 should be equal to 0. Fine, they okay, they have told us to do this. Okay, now we want to get the common ratio. Okay, getting common ratio is our main task. Okay, since, okay, now here the twist comes. Okay, and the things, okay, which you used in VN series, one thing which I told you, okay, one thing which I told you in VN series, which many teacher told, okay, that r raised to 4 plus r square plus 1 is nothing but equal to r square minus r plus 1 into r square plus r plus 1. Okay, this is multiplied. Okay, they both are multiplied. Okay, how this comes, it is based on your observation. Okay, when they give you term like this, try to use this. Okay, how I will use it, that is also a good thing. Okay, just observe, r square is 4a r raised to 4. Okay, now I will remove a. That is very simple, anyone can think that 3r square should be equal to 4r raised to 4. Okay, now removing a means that is very general. Okay, now we want to create this. To create this, you should observe that all the terms are same, means here it is 1, here it is 1, here it is also 1. How we can create 1? Here if I want to create same, and here also I have to create. So what I will do, I will here add 4, here I will add 4 to make it 7, and this also I will make 7. How? I will add 3 plus 7r plus 3r square. I will add here 4 plus 4r square. Okay, and then subtract also 4 minus 4r square. Okay, 4 r square. Okay, then here I will do what? Here I will do 4 r raised to 4 plus 3 r raised to 4 minus 3 r raised to 4. Okay, so okay, I think we should not do, we are trying to make it 7. Why? Okay, I'm trying to make all of them 7. Okay, what a mistake. Oh, okay, I'm making all the same. Okay, we will not do this. Okay, we will not do this step. Okay, just listen, I have done a mistake. Listen, the manipulation. 3 plus 7r plus 3r square. Okay, right, I will make here 7, means I will add 4 plus 4r square. That is very right, minus 4r square. What I added, what I removed, right? Then here I have 4r. Why I need to make it 7? Because I have already have 4 and 4r square. Okay, so this can act as like my this when I remove 4. Okay, like this will become 7, this will become 7r. It is already, this will become 7r square, but this will become 4r raised to 4 plus 4r square. The negative one will move this side, so this will become 1 plus r square, and this will become 4 into r power 4 plus r square plus 1. Okay, don't you agree? Now just remember what I told you, this thing, this is very important, crucial. Can I write this? Yes, I can easily write this, r square minus r plus 1 into r square plus r plus 1. Okay, if I write this, can this will cancel out? Yes, this will cancel out, and what I will get, r square minus r plus 1. Okay, so we are getting this thing. Okay, now we want, our job is to multiply them and get our answer. So what I'm getting, 4r square minus 4r, this will be 4 and 7 will come, make it 3, will be equal to 0. Okay, if I try to get its r value, it will be what? 4 plus minus, okay, add the 4 plus minus plus 4 into okay, 4 into 4 into 4 into 3, which will make it, okay, which will make it what? 4. Okay, so after this step we will write 2 by a is what? 4 only. Okay, now if I take 4 out of both of them, I will, and this will cancel, it will become 2. Okay, what inside will become 4, this 1 4 will move out, this will become 12 upon 4. If I further take out, okay, if you add on, you will get 16 upon 4. So after this there can be two possible answers, 6 by 4 comma minus 2 by 4. Okay, our answer. Okay, so which will simplify and get me 3 by 2 comma minus 1 by 2. Okay, so these are my r answers. Okay, so is there any common ratio possibles from this? Yes, second and fourth. Okay, second and fourth are the answer. Okay, now let's move on to the next question. We did nothing. Okay, just you should know this. Okay, how you will able to click this? By practice. Okay, if you practice VN series, okay, VN, the telescopic content, then you can easily observe this step. Okay, that is the difference between common student and toppers. They are not anything unusual, they just practice more. Okay, that's why they can observe these weird things which rarely appears in problems. They are able to, if you do these type of problems continuously, okay, then you will able to predict these kind of steps. Okay, now let's move on. So the next question, okay, let me get the page. Okay, this is the 10th question. Okay, the question says, if p of x, okay, which is a polynomial 1 upon x square plus x raised to 4 and so on till x raised to 2n minus 2 is a polynomial upon, okay, sorry, upon 1 plus x square and so on till x power n minus 1 is a polynomial in x, then n can be, first is 5, 10, 20, 17. Okay, so even means even if you have just understand the chapter also, you can easily observe and tell me one thing, that this is a sum of even number of terms where ratio common. Okay, if I observe this, my common ratio is what, x square. This is sum of n terms. Okay, sum of 2n terms, because here the last term is also 2n. Okay, so here it is sum of 2n terms. Okay, I mean that they are in power 2. Okay, they are all only n term only, but the last term will be multiplied by 2. That is what I am telling. Okay, so the last term will be 2n. Okay, but here if I can write it as sum of gp of n terms, and here also I can write, here the ratio will be x. So this p of x, okay, in the next the ratio is x. So in the p of x, what we can write? Okay, first term will be 1. Okay, there is no necessary 1 minus x square. Okay, whatever you feel comfortable you can write. Okay, no issue. So 1 minus x power 2n. Okay, here the common ratio is x power 2. Okay, then I put here n. Okay, many children think that I have put an x power 2n. Okay, there are no 2n terms, there are n terms only, but the common ratio is x square. Okay, that is important. And upon the common ratio 1 minus x square. Fine. But in the bottom there is also one more series, which is nothing but 1 minus x power n upon 1 minus x. Okay, so I can, okay, a square minus b square, I can apply this. 1 minus xn into 1 plus xn into 1 minus x will still be here, and this will become 1 minus x into 1 plus x, 1 minus x power n. So you can clearly see this and this will cancel out, giving me finally 1 plus x power n upon 1 plus x. Okay, now just think, okay, this should be divisible by 1 plus x. Okay, when it will be divisible by, when 1 plus xn is a factor, when 1 plus x is a factor of this. So okay, is a factor of 1 plus x. Okay, so when will this be factor? If it is a factor, then it should satisfy that x plus 1 should be its root, and it should be equal to x is equal to minus 1. Okay, then they are telling that if it is factor, then what can be the possible values of n for this n, that it will be divisible. Okay, so they are telling that just assume that it can have factors. Okay, don't get confused in this step that it can have factors or not, because they are telling is a polynomial x then n. Okay, they are asking for n indirectly, it means that it is factorable. Okay, so x is equals to 1. If x is equals to 1 should satisfy this. If it is satisfied, then p of x is equals to minus 1 is a solution of this polynomial. Okay, so let's put this value, 1 plus x power n is equals to 0. Suppose as per they have given that it should be factor to get the n value, so it should be equal to 0 since it is a factor. And in polynomial, when we get some factor, it is equal to 0. And quadratic also a polynomial, when we put its root, it becomes equal to 0, so it should also become equal to 0. And what value of x? Minus 1 power n value of x. If you observe, it will become only 0 if it is minus 1. Okay, and you clearly know if n is odd, then only it will become minus 1. So n should be odd. Okay, then only it will become 0. So what are the odd values of n which can possible? 5 is odd, 17 is odd, these two are not odd. So 5, 17 are the answer. Okay, so hope you have understand what this problem was about. Okay, 5 and 17. Okay, now let's move on. So question number 11, okay, is as follow. Question number 11 says, if n is greater than 1, the values of positive integers m for which n power m plus 1 divides a is equals to 1 plus n square and so on till n power 63 is r. Okay, is r. The first option is 8, 16, 32, 64. Okay, so n plus 1 divides. Okay, so they are telling that a power n m plus 1 is divisible. Okay, fine, they are divisible. Now you can easily see that it is a series. Okay, series. So 1 into now mainly children have error. Okay, I'm telling this 1 minus n power m, anyone can write this upon 1 minus n. Since the denominator is in this format, okay, you should write like this. Okay, so n power m minus 1 upon first term is this, n minus 1 upon nm plus 1. It should be divisible. Okay, 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 this is wrong. Okay, just you are means this is nothing different. You can take minus, okay, at any moment and make them same, no issue. But if you know that your denominator is in this form, try to take the sum in this form. Okay, so here what okay, sorry, this will be what, there are 63 terms. No, there are no 63 terms, there are 64 terms. Okay, how the 1 is coming? If the n power is 0, so 1 to 63 is nothing but 64 terms, which is 64 power minus 1. Okay, just observe this. Okay, n power 64 minus 1, here I can apply a square minus b square, so I can write this n power 32 minus 1 into n power 32 plus 1. But wait a minute, n power 32 minus 1, I can again divide this thing as n square 32 plus 1 into n square 16 minus 1 into n square 16 plus 1. But wait, again we can divide this. We can divide this n power 8 minus 1 into n power 8 plus 1. Again we can divide this. Okay, sorry, the last term we forgot, n 16 plus 1, n 32 plus 1. Okay, again we can divide this n power 4 minus 1, okay, into n power 4 plus 1 into n power 16 plus 1 into n power 8 plus 1, sorry, plus 1 into n power 32 plus 1. Okay, and then again we can divide this as n power 2 minus 1, n power 2 plus 1 into n power 16 plus 1, n power 4 plus 1, n power 32 plus 1. Okay, so that I'm writing it again, so you can understand what is happening. And this can lastly break into n minus 1 into n plus 1. But wait a minute, n minus 1 is in the denominator only, so now you will understand what is actually happening. I will break it into 32 minus plus 1 into 16 plus 1 into 8 plus 1 into 4 plus 1 into 2 plus 1 and finally n plus 1. So these last one, here n minus 1 also be there, and the denominator n minus 1 is still there, and n power m plus 1. Okay, so this will cancel out. Now how can this be divided? This, if m is equals to 32, 16, 8, 4, 2 and 1 only. Okay, so if these values are there, then it will divide 16, 32, 60, 64, no, 8, yes, 64 is not there. Okay, so 1, 2 and 3 are the answer, So the important thing was breaking it into a square minus b square. Okay, so hope you have understand that step. Now let's move on to the next problem. Okay, the next problem. Okay, this is the next problem. Okay, the next term of the GP, they are telling the next term of the GP, this fourth term, x comma x square plus 4 and x cube plus 10 is 729 by 16, second 6, 0 or 54. Okay, here what we can do, okay, apply the GP condition. That's only idea we have left with. Okay, 10 x square plus 4, x square plus 2, sorry, if I have written 4, our whole thing will have gone wrong, plus 10x, okay, x raised to 4 plus 4 x square, and here x raised to 4, fine. No, sorry, I'm making mistakes. Okay, now this will cancel out. We are going to get with 4x square minus 10x plus 4 should be equal to 0. Okay, if we simplify this, okay, we will simplify this 4x square minus 8x plus 2x, okay, plus 4 should be equal to 0, giving me 4x minus 2 into x minus 2 should be equal to 0, finally giving me x is equals to 1 by 2 and x is equals to 2. So these two values of x are possible. Now there will be means now fourth term will appear when, okay, now for fourth term, okay, for fourth term, okay, so fourth term will be what, x cube, the third term, into r. Okay, if I apply, means if I want to find the third term, I will multiply r square plus 2 into r, then I will get the third term. But how will I will get r? Okay, the two way to get r is just this, r cube plus 10 by x square plus 2, and the next way is x square plus 2 upon x. Okay, both the ways are fine, but this one will reduce our calculation, so we will use this x cube plus 10 into x square plus 2 upon x. Now let's put the value for x is equals to 1 by 2. Okay, if we put 1 by 2, what we are getting? 1 by 8. Okay, 1 by 8 plus 10, here will be what? 1x will cancel out this x, giving me 1 by 2 plus, okay, this will be 4, giving me finally 81 by 16 into 9, which will finally lead to 729 by 16. Okay, so first is the answer. Now let's check for the second one. Okay, this is the previous question solution. Okay, now let me make it a line. Now for x is equals to 2, the thing will be as it is, x cube plus 10. Okay, I'm not going to write it again, x plus 2 by x, simple. Now if we do this, okay, we would put the values. 2, it will be 8 plus 10, this will be what? 2 plus 1, which will make it 18 into 3. Okay, right, 18 into 3, giving me finally 54. Okay, so fourth is the answer. So hope you have understood. We first applied the GP general step, then we this thing is important, you can consider both of them, but here it will become square and then it will become, okay, if you know the binomial then it is fine. Okay, otherwise it will increase your issue only. Okay, so hope you have understand what I meant. Okay, so this was the solution of this problem. For first and fourth are the solutions. Okay, so now let's move on. Okay, so the next problem, which is 13th problem, is if 1 plus 2x plus 3x square plus 4x cube and so on till infinity is greater than equal to 4, then first least value of x is 1 by 2, greater value of x is 4 by 3, least value of x is 2 by 3, greater value of x does not exist. Okay, so this question, okay, if you think it is a GP, then I have to give you a medal, because you have done so many problems, we have done so many lectures. Okay, it is clearly a AGP. Okay, so I will take the steps. First I will write this as a series, 3x square 4x cube. Okay, write it as a series, and then again write it and multiply with the common, okay, ratio, which is x, and move one step ahead all the terms. Okay, this will become x, this will become 2x square 3x cube, and so on all the terms. Then we will subtract, giving me 1 minus x into s, 1 plus x square. Now it is a perfect GP. Okay, hope you can understand. Then in the next step we can write 1 minus 1 by x, but here also there is x, so this will become, okay, let me write here, this will become 1 upon 1 minus x the whole square. Okay, but wait a minute, 1 minus x the whole square is nothing but greater than equal to 4. I will move it, so here it will become greater than equal to 1 minus x the whole square. Okay, which 1 minus x is less than equal to 1 by 2. Okay, when this type of thing appears, there is means this is a variety of inequality. Okay, in which we break it like this: 1 minus x is less than, when if it there is what greater than equal to, we have to take the cases. Okay, this is a special type of means inequality. If you study, okay, then you will know this. Okay, I have not taught inequality, but just remember, when this type of inequality appears, we have to break it like this: minus 1 by 2. Okay, then here I will add what? Minus 1, so this will become minus 3 by 2, and this will become minus x only, and this will be what? Minus 1 will make it what? Minus 1 by 2. Now I will multiply throughout by minus, giving me final answer 1 by 2 is greater than equal to x greater than equal to 3 by 2. Okay, so my x lies in this. But if you think this is our answer, then you are in a big trouble, because you just forgot an important thing. For an infinite series to be possible, mod x should be less than 1. When I was teaching sequence series, I have told you 1000 times that this condition should always be valid, which indirectly means, okay, this is the modification of that form, okay, which gives us this: it should be greater than 0 and between 1. But wait a minute, 1 by 2 is greater than 0. Okay, so it should be, if I take the, okay, intersection, it should be less than 1. Okay, this is 1 point something, so it should be less than 1 and greater than 1 by 2. So greater value of 1 by 2 is fine, the least value of x by 2 is, this answer is correct. but the greatest value which should be less than 1, so it does not exist. This option is not correct. Okay, this option does not seem correct. Greater value of x does not exist. Okay, it will be between less than 1, but since there is no exact value, so we'll go with the greatest value of x does not exist. Okay, so hope let's move on to the next question. So the 14th, okay, the 14th problem, let me take this page. Okay, the 14th problem, okay, which says this one. Okay, this problem we have already done, okay, when I was teaching sequence and series. Okay, some, I think 3 or 4 problems have just just came front of our eyes again. Okay, but doesn't matter. Okay, it is just a quick second time revision which will make our concept more strong. Okay, let s1 s2 and so on be squared such that for each n greater than equal to 1, the length of the side of Sn equals the length of a diagonal of Sn plus 1. If the length of a side of S1 is 10 centimeters, then for which of the following values of n is the area of Sn less than 1 square centimeter? Okay, let me get the page. Okay, so okay, this question number 14, we have done question number 13, right? Okay, yes, we have done question number 13. Okay, now in a square, okay, length of a side, okay, if you draw a square, okay, just you can, by Pythagoras you can do this. Okay, it is nothing big. Okay, the means the length of the diagonal is nothing but root 2 times length of the side, length of side. Okay, so if I say this, that length of side Sn, okay, length of side Sn, because that is what, okay, the length of side Sn is equal to the length of diagonal. Okay, so it should be equal to root 2 times length of the side this, but it is giving it is equal to the length of the diagonal. So length of the okay, the length of the side is equal to this is okay, wait a minute, this, the length of the side is okay, length of, wait, the s1 s2 are the sides of the b s1 s2 b square such that for each n greater than equal to 1, the length of the side of Sn is equal to the length of the diagonal of Sn plus 1. Okay, the length of the side is equal to the length. Okay, but we know that length of the side is equal to under root 2 times the length of the diagonal. Okay, so length of the diagonal is under root 2 times length of the side. Okay, so what we, okay, listen, they are telling that length of the side is equal to, okay, they are telling length of this side Sn is equal to length of the diagonal Sn plus 1. Fine, this is they are telling, but we know that length of the diagonal is under root 2 times length of this side Sn plus 1. So length of side Sn plus 1 upon length of side Sn is equals to 1 upon root 2. So b upon a, okay, just take this, that the bigger term upon smaller term. Okay, it is nothing but r. Okay, so we got the r of the GP which they were telling. Okay, s1 s2 be the squares. Okay, so we got the sides. Okay, common ratio. So we know that the s1 is 10. Can we get Sn? Very easy, a r power n minus 1, which will give me a is what, 10. First side r is 1 upon root 2 n minus 1, which I can modify 10 upon 2 power n minus 1 by 2. Okay, now let's me take the next page. Here if you observe, they're telling that it is less than, okay, the area, okay, sorry, area of Sn will be what, side square, side of Sn square, but we know the Sn side is nothing but 2 power n minus 1 by 2, the whole square, which will give me 100 upon 2 power n minus 1. This square will cancel this denominator 2. Okay, so here we are left with, so it is what, it is less than 1 centimeter, square centimeter, so which will give me 100 should be less than, okay, will always be positive, so I can move it to power n minus 1. Even if it is become 1, it will be 0, which will be equal to 1, so it will always be positive. Okay, one thing is clear. Now here just observe that the lowest possible value, okay, which can be, okay, for which it can be true that it is means greater than is it is n minus 1. Okay, this can become the possible value 2 power 6. Okay, here we want to means get just less than, okay, but if you observe 2 power 100 is not possible. 2 power any number which will give you 100, no, that 2 power 6 is the closest possible number. Okay, 2 power n minus 1. And here why we can take the closest possible, because it is inequality, it is not equality. Equality we have to take exact, so it would be 10 power 2. Okay, but here since inequality, so we can do this step. Okay, that is important, that we are writing 2 power 6. Okay, why we didn't require 2 power 5, because 2 power 5 is much less than, okay, we want to just move closer to 100. Okay, because that also will be less than this. Okay, hope you are understanding what I'm telling. So n minus 1 should also be less than 6, which will give me n should be greater than 7. So n should be greater than, so possible values of n can be 8, 9 and so on. Okay, till n. So here what possible are 8, 9, 10. Okay, 3 are answers. Okay, so hope you have understand. There are n. Okay, they are telling this condition, length of the diagonal under root 2 times length of this side. Okay, I told you can derive this by Pythagoras theorem. Then S1 is I know. Then we observed that this is common ratio. Sn we applied, we got Sn's, okay, Sn length. Then we know area of Sn is nothing but side square. We did that. Okay, then we applied the inequality closest possible, and then we got our answer. Now let's move on to the next question. The next question is this question, which is 15 question, which we have also done, okay, in our previous when I was teaching sequence and series. Okay, so the question says if a comma b and c are in GP and x and y respectively be arithmetic means between a comma b and b comma c, then, okay, the conditions are a by x plus c by y is equals to 2, a by x plus c by y is equals to c by a, 1 by x plus 1 by y should be equal to 2 by b, and 1 by x plus 1 by y is equals to 2 by ac. Okay, now if it is in GP, b square should be equals to AC. This is a GP condition. If a b has x in between and b and c have y in between, then x will be nothing but a plus b by 2, y will be nothing but b plus c by 2. Okay, so we have x value, we have y value. Can we substitute here and check it is equal to 2? If it will satisfy, then this is right. If it will not, this will satisfy, okay, then this will be right. Okay, so multiple correct, we never know what can happen. A plus b by this will 2, and this will be c upon b plus c by 2. If I substitute, 2 will cancel. Okay, we want to check whether it is equal to 2 or not. Okay, we don't know it will come 2 or not. 2 into b plus c, 2c into a plus b, okay, upon ab, I am multiplying it, ac b square bc, which will give me 2ab plus, okay, 2 will I will take common, ab plus ac plus bc upon what, this will become what, ab plus b square I can write as ac. Using this b square I can write ac, so it will become 2ac upon bc. So here they will cancel out, okay, giving me 2. So first one is correct, so which indirectly means that this one is incorrect. So we will check this one, we will divide by a plus b. Okay, we are checking third one. If this one is true, then this was wrong. If this one is true, this one is wrong. A upon b by 2 plus 2 upon b plus c should be equal to what, 2 times, okay, b plus c plus, okay, I will do here, b plus c plus a plus b upon ab plus ac plus b square plus bc. Okay, and 2 will come common again. Okay, now here what we can do is that b plus c, okay, plus ab, okay, 2b will be there, and ac, fine. And here I can write ab, and I can write this ac as b square. This will become 2b square plus bc. Now I can take b common, 2 upon b, and if you observe 2b plus c plus a, the numerator upon denominator, if I take b common, b plus 2b plus sorry, here it will be a plus c, they both will become safe, giving me final answer 2 by b. Okay, so this is our answer. Okay, hope you have understand what I meant. Okay, so this is our answer. Now let's move on to the next question, which is third one. Okay, so first and third are the answer. Now let's move on to the next question. The next question is this one. Okay, consider a sequence an with a1 is equals to 2 and an is equals to a square n minus 1, a square n minus 1. Okay, this is a square n minus 1 term. Okay, a n minus 2. Okay, for all n greater than equal to 3 terms of the sequence being distinct, given that a2 and a5 are positive integer and a5 is less than 162, then the possible values of a5 can be what? Okay, now here okay, a1 is given to an is a square n minus 1 upon n minus 2. Okay, if you can I've studied sequence series properly, then you can clearly identify this condition. It tells that an minus 2 into an is equals to a square n minus 1. Doesn't this reminds you of something, that an minus 1 and an are in gp? So and this will be true for all terms for n greater than equal. So a3 and so on till an minus n are in gp. Okay, and first term is given. Okay, if I consider a2 as some m constant, okay, but it is true for a3. Okay, how we can do this problem? A3 is, it is valid till n greater than equal to 3. a2 we have considered, we cannot. Okay, there is an error in question. This condition should not be there, then only this will be true. Okay, otherwise this question will be wrong. Okay, so if this condition not there, it will be true for all the terms. So a1 a2 all are in gp. Okay, so if I consider a2m, a3, a1 I take a1 I have 2, then according to this condition m square should be equal to what? M square should be equal to, sorry, m square. Okay, m square should be 2 into a3. I got my a3, which is nothing but m square by 2. I want a5 indirectly in it, because the possible value of a5 I want. For that I will try to find a4, a3, a2. I will take these three terms. Okay, a2 m, okay, into a4, okay, a3, a2 means m into a4 will be what? M raised to 4 upon 4. Okay, because this is m square by 2. If I do square, it will become m power 4. So this will cancel out, giving me a power 4 as nothing but m cube by 4. Okay, so I got this one. Okay, now after this I can identify that my common ratio is nothing but m by 2. So I will multiply this by m by 2, giving me my a fifth term as m raised to 4 upon 8. Okay, so my terms are as follow. Okay, let me take the next page. Okay, let me do here only. Here in my terms are what? 2 m square by 2, third term m cube by 4, fourth term m4 by 8, and so on I can find. Okay, now what they're telling, that m raised to 4 by 8 is less than equal to 162. Okay, which will give me, okay, if I multiply, what I will get? I can get something like let me multiply. M raised to 4 will be what? 1296. Okay, and if I take square, I will get under root 36, which will give me m is equals to less than 6. Okay, if I take again square, I will get m is less than equal to 6. Okay, I got m should be less than 6. Okay, so now let's think. Okay, now here if you read one more statement, they are telling a5 are positive integers, a2 and a5 are positive integers. For it to be positive integer, m power 4 by 8 should be positive integer. When it will be possible? Okay, it should be positive integer. Okay, when this will be possible? It will only be possible, okay, when m is even. Okay, m is even. Okay, it will possible, because if m is even, then it will divide this and become an integer. Okay, otherwise it will be a number of p by q, it will not be an integer. Okay, there is difference between p by q number and integer. Okay, so what we will do, we will try to consider all the possible terms before 6. Okay, so the possible terms can be what? It can be okay, it should be even. Okay, so the possible term can be which we consider is m is equals to 2 we can consider, 4 we can consider, and 6 we can consider. Okay, but if you remember, this is not possible. Why? Because the first term is already 2. Okay, if this becomes 2, then the observe the series will become same. This is 2, this is 2. How can this be GP? This is not GP. So m is equals to 2 we will reject. Okay, because if this becomes 2, this becomes same, then this will be not be G, because they both are same number. 2 to m cannot be 2. So if m cannot be 2, then what can be m? So m power 4 will be what? 256. For m is equals to 4, it will be, okay, let me take the next page only, because here I am not getting space only. So it will be 4 power 4 by 8 one term, another will be what? 6 power 4 by 8, which will give me, the first will be 256 by 8, which will be nothing but 32, right? And the next will be 6 power 96 upon 8, which will give me 162. Okay, so 162 and 32. Okay, so first and third are the answer. Okay, hope you have understand what we did. Okay, what was the mistake in the question. Okay, otherwise we cannot consider all of them in GP. When we consider them, the missing term we taken as m and find the last term, then we identified the r, we got the r, then we consider the fifth term, we applied this condition. After applying this condition, we simplified them and then identified the condition for the possible values of m, that m should be even for it to be a positive integer. Then the possible values of it for even is 2, 4, 6, but 2 cannot be, because the number will become same and the sequence will not be the series will no longer be a GP. So is the sequence will no longer be a GP. To avoid that, we consider 4 and 6 can be the possible values of m. When we consider 4 and 6, we got these answers. Okay, hope you have understand. That is what 1 and 3 are the answer. Now let's move on. The 17th question, the number, okay, sorry. Okay, the number 1 comma 4 comma 16 can be 3 terms. Okay, not necessarily consecutive. Okay, no AP. Okay, they can form AP, only one GP, infinite number of AP, infinite number of GP. Okay, AP is very easy. Okay, if you remember the previous form questions of this single correct only or multiple correct, okay, which we are doing. Okay, there was a simple condition that if there are pth, qth and rth terms, okay, if I want to prove that they are in APGP, the condition was rth minus qth upon qth minus pth term should be rational number. If that is true, if the rational number, that is a number of rational number, then they can form infinite number of AP. So let pth term be 1, qth be 4 and rth be 16. So according to that, r minus q upon q minus p will be what? Okay, you can solve this by applying formula that q term is equals to a plus q minus 1 into d. Okay, the same answer will come. This is nothing but q term is what? 4 is equals to a plus q minus 1 into d. Okay, like that. Okay, this thing will become after, if I subtract this, I will get only this, only 16 minus like that. Okay, so here will be what? 16 means 16th minus 4 upon q will be what? 4 minus 1, giving me 12 upon 3, which is nothing but 4. So a rational number appeared, which means infinite number of GP AP are possible. Okay, so we have verified this. Now the fourth one, let's check fourth one. Okay, if we check the fourth one, infinite number of APs. Okay, infinite number of APs. Now how to check that? If I consider 1 as the first term, okay, it is fine. The second term 4 is equals to a, one term into r power, okay, n. Okay, let's say it is n term. Okay, some n term, and the 16th is nothing but r power m term. Okay, but in GP, the way we check that infinite GP or 1 GP possible is like that we have to compare them. Okay, if you got the nature, then your job is done. Okay, like how we can predict that this r power n is twice, because it is 14, then it is 16, it is just its square. So r power 2n should be equal to r power m. Don't you agree about this? This, if I square, I will get this 16, which means that this square will be equal to this, if which I compare to n should be equal to m. Okay, should be equal to some constant, or doesn't matter. How many numbers can satisfy this condition? There are many numbers which can satisfy the condition. Infinite numbers. Okay, if there was only one condition, then only 1 GB would have been possible. Okay, we will see this type of problem also, but here n numbers are possible, so infinite number of GP are possible. Okay, if I here took 1 by 2, and here if I take 1 by 4, here if here I take 1 by 2, okay, then they will satisfy the condition. Okay, there can be infinite number of pair of terms. Okay, pair of terms, not the same terms. Many children do one mistake, that they say that n is something 2 and m is also 2. Then how can they be equal? Arey bro, listen what I'm telling, just listen this, that if it is 2 and this is 2, how can they be equal? They will never be equal. If they are same term, then m is equal to n. You have proven that m is equal to n, then there is no sense of doing this, that the term position are same, that the qth and r term are same. So just be conscious while solving the problem. Okay, now as per this, fourth and third are the answer. This was the condition for infinite AP to be possible. This was the condition for infinite GP to be possible, because n number of terms, pair of terms, okay, pair of terms can satisfy this condition. Now let's move on. 18th term. Okay, the 18th question, sorry, okay, how does it? Okay, so the 18th question, the sum of an infinite series is 162 and sum of its nth term. Okay, sum of its nth term is 160 if the inverse if inverse of its common ratio is an integer. Okay, so 1 by r, okay, is an integer, then which of the following is /r possible first terms? Okay, so s infinite is given 162, s n is given 160, the sum of the first n terms. Okay, the sum of infinite terms is 162. Okay, and the sum of n terms is 160. Fine. So what we can do here? Okay, here we can do this thing, that this will be what? S infinite will be nothing but a power 1 minus r, and this will be nothing but a into 1 minus r power n upon 1 minus r. If I divide, since this is bigger number, 160 by 160, this will give me a upon 1 minus r, and this will be a into 1 minus r power n upon 1 minus r, giving me, they will cancel out, my final answer will be 1 upon 1 minus r power n. Okay, and this will simplify. Okay, 1 minus r power n, this will simplify as what? This will become, 162 upon 160 is nothing but 180 upon, 81 upon 80. Okay, 81 upon 80. So what we can do after this? Okay, we will move it that side and bring it that. So 80 upon 81 will be 1 minus r power n. We will move r power n here, and we will divide 80 upon 81 this, which will give me 1 upon 81. So now I will do what? Bring 81 here, 1 by r power n the whole square. Now for 1 by r to be an integer, okay, 1 by r to be an integer, okay, 1 by r, if here it was r, then you can say that r to be integer, but here 1 by r should be an integer. Okay, so what can be the possible values of r? So here for it to be possible values can be 3, 9, 81 can appear in 3, 9, okay, and 81 where n is equals to 1. So for these 3 will appear when n is equals to what? N will be 4, when 9 will appear when n will be 2, and 81 will be appear when n will be 1. Okay, so these conditions are very general. Okay, this condition will occur, then they will be equal. Okay, when n is equals to this number. Okay, then we can using this equation we can easily find the first term. First term will be what? Let me solve it here. Okay, this was previous question. Okay, the first term will be easily 1 into 162 into 1 minus 1 by 3. Okay, if I take r is equals to 3, so it will be 1 by 3. Okay, if I solve this, what I'm getting, 3 minus 2, okay, 162 into 2 by 3, giving me finally 108. Okay, and here if I solve this, 162 into 1 minus 1 by 9, giving me what I will get, 144. And while if I solve this one, 162 into 1 minus 1 by 81, I will get 160. Okay, so what are the answers? 108, 120 is there, no. 144 and 1, so 3 are the correct answers. Okay, what we did, we find s infinity, we find s, and we divided by checking what is increased and what is small, cancel out, getting lastly this, and then we moved that side and then separated rn, then identified here, okay, which by what can be the possible values at what n, okay, and then we just put the values and calculate the possible answers. Okay, now let's move on to the next. Okay, next question. Okay, 19th question. Okay, which is 19th question. Okay, our page was incomplete. Okay, our page was incomplete, means this page, okay, I should have taken it, is not complete. Okay, this is question number 19th. Okay, it says 1 upon a comma 1 upon b comma 1 upon c are in ap, and a comma b comma minus 2c are in gp, where a comma b comma c are non-zero. Then here a cube plus b cube plus c cube minus 3 abc. Okay, second is minus ab minus 2a minus b, sorry, b comma minus 2c are in ap. Third is a square minus a square comma b square comma 4c square are in gp. Roots of the equation ax square plus bx plus c equals to 0 are real. Okay, so how we can solve this now? 1 by a, 1 by b, 1 by c are in ap. For okay, they are ap, so b value can be easy 2ac upon a plus b. How I got it? 2 by b is equals to 1 by a plus 1 by c. Okay, if you have not understand, a plus c upon ac, b will be nothing but 2ac upon a plus b. Okay, okay, and here since it is gp, b square is equals to nothing but minus 2ac. Okay, I got this thing, I will keep it as, okay, this as 1, this is as 2. Okay, now if I substitute here this value, 2ac will nothing but minus b square, so b is equals to minus b square upon a plus b. This will cancel out, giving me a plus b is equals to minus b, and a plus c, a plus c, a plus c, a plus c is equals to, which will give me a plus b plus c should be equal to 0. Okay, the first option, okay, keep it as my a main. Okay, now the first option we can easily check it out. Okay, but it is the toughest also. Okay, it is easy and toughest. How it can be possible? Now listen, if your 10th concept are means strong, then you will easily predict out that this is a formula which we have studied in class 10th RD Sharma many times. Okay, what was that formula? This was that formula, a cube plus b cube plus c cube minus 3abc. Okay, they asked, okay, they means they, this is the favorite topic. Okay, this formula is, means they use it many times, a square plus b square plus c square minus ab minus bc minus ca. This is the formula. But wait a minute, a plus b plus c is equals to 0, then a cube plus b cube plus c cube minus 3abc is equals to 0. But wait a second, a plus b plus c is also equal to 0, then they are equal. Okay, but it's true that we came from the solution only, so 1 is correct, 1 is correct. Now let's check for this one. If it is in AP, then twice b should be equal to minus 2ab plus minus 2c. Okay, if I divide by b, it will be minus a minus c. Okay, if we check from this, b is nothing but minus a minus c, so the second one is also true, so second is also the answer. Okay, you can see how the answers are coming. Okay, and now let's check for this one. B square b raised to 4 will be what? A square into 4 c square. But b, this is what? B square power whole square, which will be nothing but minus 2 ac the whole square, which will be nothing but 4a square c square is equals to a square 4c square. But they both are equal, so this is also true, so c1 is also true. Okay, how we write that b square is equals to, because here you can see in the second one they have given, so we have used that. Okay, now the roots of the equation ax plus bx plus c is equals to 0 are real. Okay, this one is quite tricky. Okay, and if you have done the quadratic chapter from me, then it is just a step, because I have told you, you have to approach the problems like this also, that whenever if they give you some equation like ax bx plus c equal to 0, okay, and if you try to tackle the problem, there are two ways to tackle, by hit and trial and if you know the roots. But here we don't know nothing about the equation, except here we can create a plus b plus c as if a equation is equal to 0, it means for what x it is equal to 0. If I put x is equals to 1, then a plus b plus c is equals to 0, so the equation is becoming equal to 0 for some x value. So this is a root, this is a root. If this is a root, then root is real, root is real. Now how we can check the second root? Okay, can we use alpha plus beta? Can we use alpha into beta? No issue, but it will increase your time only. The best way, the better way to check that is that you know one root is real. The other root can be rational or irrational, doesn't matter. Okay, it will be real. It will be real. It will be real. Why it will be real? Because complex root exist in pair. Exist in pair. So if one root is real, the other will surely be real. So fourth is correct. Okay, so in this way you have to tackle the problem. This thing is told in quadratic, means in 1000 times. I have told this 1000 times, this trick. Okay, complex root exists in pair, and since one root is real, the other root will surely be real. Whether it be rational or irrational doesn't matter. Okay, so now let's move on to the next problem. Okay, all four are correct. Okay, this problem is quite tricky. Okay, now let's move on. Okay, this page is not completed still. Okay, this is the problem. Okay, 20th problem. Sum of an infinite GP is 2 and the sum of its first two term. Okay, sum of the first two term is 1. If its second term is negative, okay, then which of the following is and are true? Okay, second term is negative. Okay, so which of the following is true? Okay, the sum of infinite is given 2 and sum of infinite of first two terms, matlab a1 plus a2 is equals to what? Is 1. Okay, then I can write it as a and I can write it as r, should be equal to 1. But this is what? 1 upon 1 minus r is equals to 2. So can I put the value of a as 2 into 1 minus r here? Here I will put the a value. This is 1 plus r equal to 1. If I substitute where I get 1 minus r into 1 plus r is equals to 1, which will make give 2 minus 1 by r square is equals to 1, giving me 1 minus r square is equals to 1 by 2. This will become, this 1 by 2 will move here and this will be r square. Finally r will be plus minus 1 by root 2. Okay, then which of the following is true? Okay, so r can have two values. R is equals to minus 1 by root 2, r is equals to 1 by root 2. Okay, which one we have to take? We have to take both. Okay, now for how can we find the a will be nothing but 2 into 1 minus r. Okay, here 2 will move 2r. Okay, fine. So if I take, okay, let me do it here. If, okay, if r is equals to 1 upon root 2, positive 1, then a will be what? 2 minus 2, 1 upon root 2. This will become 2. I will rationalize this, multiply and divide by root 2 will give me 2 into root 2 upon 2, which my final answer will give me 1 minus root 2. 2 minus 2 root 2. 2 minus root 2, sorry. Okay, 2 will cancel out. Okay, so is there option one of the possible value first term is 2 minus root 2. Okay, now check if r is equals to minus 1 by root 2, a will be what? First term will be what? 2 minus minus, okay, 2 into minus 1 by root 2, which will make it 2 plus 2 by root 2 again, but this time 2 plus root 2. Okay, so the second one is also correct. Now can we check the one of the possible values common root is, okay, no, it is 1 upon root 2, and one of the possible common, okay, this one is fourth, 1 upon 2, 1 upon root 2. That's why if you read the multiple correct question, try to check all the options in the starting only, because here we didn't check. That's why we checked it in the end. If we have checked it in the starting, we would have more confirmed that our root is 1 by root 2 is correct. There is no error while calculating. Okay, so that would have double in short, but doesn't matter. Okay, so this was our 20th problem and three options were correct. Okay, and we are done 20 problems. Okay, in the next lecture we will do some more problems of multiple correct and try to wind it up as fast as we can. Okay, and thank you for watching these lectures and solve this. Okay, take care, see you in the next lecture.